All right, section 4.2, some ways to prove that triangles are congruent. First of all, I'm sorry that this light bulb in here keeps flickering. I hope that doesn't bother you as we go through this. We will persevere. So what we've learned in section 1 is that we know that polygons or triangles are congruent if all the parts, all the sides, all the angles are congruent. Well, there are other ways. There are there are actually 5 ways. We're going to learn 3 of them here in this section. We'll learn the other 2 next time. The first one is called the SSS postulate, which stands for side, side, side. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So over here on the right-hand side, the abbreviation for that, of course, is SSS. GH is congruent with PQ. HF is congruent with QR. GF is congruent with PR. So all 3 sides of this triangle are congruent with 3 sides of that triangle, which means those triangles are congruent. So we can make these congruency statements. Remember that when you make a congruency statement, that if you lead with F, you got to lead with R, because it's F and R are the corresponding sides. So just be very careful when you name these things. If you name the first one PRQ, the next one better be GFH. There's multiple ways to name these, but they have to correspond. That is the key. So the order matters. So, and therefore, because of corresponding parts of congruent triangles are congruent, CP, CTC, that all of these parts are congruent. Even the parts that don't say that they're congruent are now congruent. Once you say the triangle is congruent, everything is congruent. The next one is the side angle side. So if 2 sides and the included angle, let me explain what this is talking about. If you got this triangle down here, if you're talking about this side and this side, the included angle is the angle that is created by those 2 sides, the angle that is in between those 2 sides. So this angle over here is not the included angle of these 2 sides, it would be included of these 2 sides. So when we talk about if 2 sides and the included angle, the one is between those 2 sides of one triangle are congruent to the 2 sides and the included angle of another triangle, then the triangles are congruent. And we'll call this side SAS, which stands for side angle side. I made that up myself. So here we got FD is congruent with BC. We have that angle D is congruent with angle C, and then also CA is congruent with DE, because we have a side, an angle, a side, side, included angle, side. We can then say those angles, or those triangles, are congruent. Remember to be careful, make sure that the appropriate angles correspond, such that if we look over here, that we look at DF, that better corresponds with CB over here. DF corresponds with CB. And so now all of the parts are congruent. So angle C, of course, is congruent with angle D, but we can also say that any of these parts over here, angle A is now congruent with angle E, FE is congruent with BA, etc. Now that we've established the triangle's congruent, everything is congruent. All right, so that's side, 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 and side angle side. Oh, and do remember, the reason for this is for the CPCTC. The corresponding parts of congruent triangles are congruent. All right, one more that we're going to cover here, the ASA postulate, which, could you guess what that stands for? Very good. It is called the side angle postulate. If 2 angles and the included side, just like we talked about, the included angle is the angle in between, it's the side that is in between the 2 angles. So angle, included side, angle. If that's true for one triangle, if they are congruent to 2 angles and the included side of another triangle, then the triangles are congruent. So over here, we've got angle G is congruent with angle K. We've got segment GH is congruent with segment KN, and we've got angle H is congruent with angle N. We have angle included side angle is congruent with angle included side angle. So therefore, the triangles are congruent. We can now say triangle GHP is congruent with angle or triangle KNP and make all of these other statements. And because of CP/CTC, we can make these statements as well. Okay, so the first type of question that you'll be answering from these is, do we have congruent triangles? Can the two triangles be proved to be congruent? If so, write the congruence and name the postulate used. So let's look at example A here. Well, clearly we have this side's congruent to this side, this side's congruent to this side. We have two sides that are congruent. Do we have the third side that's congruent so that we could use side, side, side? No, we don't. Do we have the included angle that's congruent? Well, those are vertical angles, yes. So we can say that side included angle side is congruent to side included angle side. And now be careful when you make your statement that everything matches up here. Clearly the O is going to match up, but PO has to correspond with TO. Be careful with how you write your correspondence. Example B. Likewise, we have a side and a side, a side and a side. We have two sides that are clearly marked as congruent. Do we have an included angle? Is angle B congruent with angle D? No data supports that. Is the third side congruent? Oh, AC is in both of them. So yes, because of side, 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 we have these two triangles congruent. Be careful that BA corresponds with DC. That AC corresponds with CA. If you just do a check to make sure that all three of those segments correspond with each other. It's easy to get those ordered backwards. Let's look at example C here now. Got a right angle, got a right angle. Got a side, we got a side, and we have an acute angle, acute angle. What's the reason that we're going to get angle, side angle, and then be careful with how you write your correspondence. Make sure that each of those pieces match up. Okay, let's look at example D. We have clearly marked a side and a side. We have an angle and an angle, and yeah, we have a reflexive, EG is in both of them. So do we have side, angle, side, right? Side included angle, side, side include. Wait, the angle is not included between these two sides. So this is not side, angle, side. This would be more like side, side, angle, or even worse, angle, side, side. We don't want to talk about that one. So are these congruent? No, it's not. That angle is not included between those two sides. So we don't have side, angle, side congruence. When you're doing these things, always look for the following. Look for vertical angles, like you saw in question A. Look for shared sides or angles, like we saw in example B and D. Also, look for parallel lines. If you have parallel lines, you probably have alternate interior angles or corresponding angles that are going to be congruent. So those are major clues that you're going to see a lot. Assuming that you're paying attention, I know that you are. Over to the right over here, right, don't look for horizontal angles. Thank you very much. So I'd like for you to go ahead and try these 1 through 8 you're looking for these three qualities: side, 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 side angle, side, or angle, side, angle. Pause the video and answer these 8 questions. How'd you do in the first 3? We had side, side, side on number 1, angle, side, angle on number 2. The side, side, angle, or even worse, angle, side, side, but we can't say that one out loud, doesn't work. No, that one is not. How'd you do on number 4? Parallel lines. Parallel lines. Alternate interior angles are congruent. Did you catch it? So yes, side, angle, side. We had the reflexive side there. Number 5, parallel lines. Yes. Number 6, angle, angle, angle? Don't think so. Number 7, could it get any easier? Number 8, a little bit tricky here. We got this piece, these pieces are congruent, those pieces are congruent, and so is this here. So if DB is congruent with YW and DA is congruent with YZ, is DA congruent with YZ? Z. Do you remember the addition rule? Well, sure you do. Side angle side. Those are indeed congruent. All right, the rest of this, these are filling in reasons for proof. Not any different than what we have done in the past. So I think you can try it. Go ahead. Pause the video. Do it. I know you can. Think positive thoughts. The main question you'll have right here is, why are these angles congruent? The key is from the parallel lines, which hopefully you've paid attention there. So we have angle side angle there. Given this has meaning, y'all. When it tells you that something bisects, that has meaning. What does it mean? What does it mean to have the definition of a segment bisector? Segment bisectors create midpoints. So D is a midpoint. And I didn't emphasize this on the first one, but when you get something, when it tells you that something is congruent, mark it on here. When it tells you that AC is congruent with BC, mark it on here. What does it mean for D to be a midpoint? That means that those two segments are congruent. Mark them. Reflexive side, that's in both of them. What's the reason we have those side, side, side? I hope you did well. Get some rest. There's going to be a lot of stuff coming up your way. Love you, bye.